Hi students, welcome to another video on fundamentals of electronic circuits. Before we start, so let us see these important slides. What you need to know before you begin is, so you should know Ohm's law. So you should know how to find the resistance, the voltage and current across the resistor and through the resistor, capacitor and inductor. You should be knowing Kirchhoff voltage law and Kirchhoff current law. Uh, what you need during this lecture is you should have a notebook, few pens of different colors. Of course, more importantly, make sure that you are turning off all distractions. To get most from this lecture, set aside at least minimum 1 hour. Write down everything. Of course, pause the video if you want to catch up. Write while writing something and solving the problems, and of course, do participate in solving some task. So let us proceed with uh, this is the circuit diagram what we have. The task here is to find the current through each of the resistor and the voltage across each of the resistor. Of course, naturally you can also find what is the power dissipation by each of the resistors. So if I name this as current I1, if this is current I2, this is current I3, this is current I4. This is voltage V1 across the resistor. Now this is plus minus, and this entire voltage is of course all these resistors are in parallel, so you won't have the same voltage. If it is V2, it is plus minus. So from our KCL, Kirchhoff current law, if you consider this as node A, so I have to write KCL to a particular node. So current entering the node is equal to I1, and the currents leaving the node is I2, I3, I4. So it is I2 plus I3 plus I4. This is what your Kirchhoff current law says. So current entering the node is I1, the current leaving the node are I2, I3, I4. Entering the node is equal to leaving the node. So coming to Kirchhoff voltage law. So in a closed loop, suppose you consider this as V in. So this is, suppose you consider this as V in. Suppose you start from here and then again come back to same. So it's your closed loop. So if the current, suppose if you consider the voltage rise as negative or maybe positive. So this is V in is positive because it is voltage rise, and you have a voltage drop, which is, I can write it as minus V1, and there is another voltage drop, it is minus V2 equal to 0, or you can write V in is equal to V1 plus V2. So this is your Kirchhoff voltage law. So using Kirchhoff current law, you can write this. Kirchhoff voltage law, you can write this. Now we are supposed to find, so what are the currents through each of the component. So for that, so let us first simplify the values of this parallel combination. So what I have now is, so now I can rewrite this circuit diagram into a modified one. So this R1 is 100 ohm. I can actually make these two series as a single resistor, and then these two are now. So I will take this R2 and I will make it as some R equivalent. So this R equivalent is actually equal to R3 plus R4 inverse plus R5 inverse whole inverse. So what is that value comes out to be? That value comes out to be, just find out. So it is now, so this is 470 ohms, 470 ohms. It is 470 into 2 inverse plus R5 is 100k, 100 exponential 3 inverse equals and whole inverse. So what happened? So this is, so it is now So it is 470 into 2 inverse plus it is 100 exponential 3 inverse equals, and inverse of that is actually 931.24 ohms. So this is the resistance of this R equivalent. So now that is in parallel with R2, which is 1 kilo. So now this I will take it as, so it is now 931. So now you have this is 100 ohm, and let me say this is R equivalent to, this is R equivalent 1. So what is R equivalent to? It's actually R2 inverse plus R equivalent inverse whole inverse. So it is 231.24 inverse plus 1 exponential 3 inverse equals, and then 1 over that, it's actually 482.19 ohm. So this is 482, then this equivalent circuit becomes, so then this is now 100 plus, this is 100, this is R equivalent to, which is 482.19. So this is 100 ohm, that's what is taken. So this is your I1. So how much is now I1? So I1 you can write it as 100 volt divided by 582.19 ohm, which happens to be a current of, it is 100 divided by 582.19. 582.19. This is now, so if you just say that it is 171, so I1 is, 171.76 milliampere. So this is I1, which is 171.76 milliamperes. So once you know I1, so I want to know what is I2. To know I2, what you should know is, as we found in the previous case, suppose this is a previous video, if you know the main current of these two branches, so then it is easy to find what is I2 as well as I3. So what is I2 now? So let me just write the expression for I2 and I3. So what is I2? I can write as per this. I2 is equal to I1 multiplied by the resistance of the other arm, which is R equivalent 1 divided by R2 plus R equivalent 1, which happens to be, it is 171.76 exponential minus 3 multiplied by, this is how much, 931.24 equals, divided by, it is 1 exponential 3 plus, it's R2 and R equivalent is 931.24. If I close it, you can see now it is 82.82 milliampere. So this is the current now, 82.82 milliampere. 82.82 milliampere is the current flowing through I2. So naturally I3 is equal to same I1 into resistance. So now if you want to find this, you know this current. So current flowing to this is main current multiplied by the resistance of the other arm divided by the sum of those two resistors. How much is this now? So it is now, how much is I1? It is 171.76 milli multiplied by R2 is 1K divided by 1K plus 931.24. Let me do that. 171.76. Okay, let me just take out that exponential minus 3 into 1 exponential 3 equals divided by 1 exponential 3 plus 931.24. It is now 88 point. Of course, since now if you can see it is 0.08 something, just press that ENG, you'll get it as 88.93 milliamperes. So from this, I1 is equal to 170.76 milliampere, I2 is equal to okay, let us just wait for this. So this I3 is this, we named it as I3, but that is not this I3. Let me just write it as I3 dash. So this is, let me write it as I3 dash. So let me write it as, what is that? This is I. Okay, this current is different from this. So since we named it as I3, let us name this as I3 dash. So this is I3 dash. So I2 is how much? 82.82 milliamperes. So you know what is I3 dash. So I3 dash is the overall current flowing through the parallel combination of these two. So what is this? I3 dash happens to be much 80, what is that? 88.93 milliamperes. So it is what is the current flowing through these two arms. So now if you want to find I3, the main current of these two branches is nothing but I3 dash. It is I3 dash into resistance of the other arm, which is R5 divided by R3 plus R4 plus R5, because these two are now in series. So it is, what is this? So what will be this now? How much is I3 dash? It is 88.93 exponential of minus 3 into, how much is R5? R5 is 100 exponential 3 divided by 100 exponential 3 plus 470 plus 470. This happens to be 88.1 milliamperes. This is what is I3, exact I3. So I3 is this. How much is I4? I4 is actually I3 dash minus I3, or I3 dash into R3 plus R4 divided by R3 plus R4 plus R5. So both have to be same. So what is that we are trying to do is, we know this I3 dash. We know this current is actually I3 dash, which is equal to, which will be now divided between I3 and I4. We already know what is I3 is. To find I4, it is I3 dash into resistance of these two series, which is 470 plus 470 divided by the sum of all the 1, 2, 3 ways. Because we are not considering R2 now, because R2 we already know what is the current flowing through that. So what is this? It is now again 88.93 milliampere into 470 plus 470 divided by 470 plus 470 plus 100k. This is the value, which will be 88.93 exponential of minus 3 into 470 plus 470, okay, equals divide by 470 plus 470 plus 100 exponential 3, which will be a very small current. I can see it's there in 10 power minus 4. Let us bring it to micro. It is now 828.15 microamperes. What is I4? So let us list out the currents what we got. So let me rewrite the circuit and the currents. So circuit what I have is this. This is the circuit. This is I1, I2, I3, I4, R1, R2, R3, R4, R5, grounded 100 volt, I1, I2, I3, I4, values are, how much is I1? It is 171.76 milliamperes. What is I2? I2 is actually I2. Where is I2? I2 we found it here. Which is I2. This is this 82.82 milliamperes. I3 is 88.1 milliampere, and this is maybe you can write as 0.0828 milliamperes. So this can be written as 0.828 milliamperes. That's what is 8.8 milliamperes. Let us find what are their simulation currents. So simulated values. So let us find what is V1 is equal to. And of course, we can also verify that Kirchhoff current law, voltage, all those stuff. Okay, we'll do that. So what is V1? V1 is equal to I1 into R1. How much is R1? R1 is actually 100 ohm. So it is this into 100. So 171.76 exponential minus 3 into 100. It's actually 17.176 volts. This is V1. So entire V2 is again the same current I1 multiplied by the overall equivalent resistance. Overall equivalent resistance is how much? Overall equivalent resistance is this one, 482.19. So it is how much? So how much is I1? I1 is the same, 171 point something. So how much is the resistance? The resistance now is 482.19. If you see, this is 82.82 volts. We know that if I say this is V in, what we said here, this is V in, V1, V2. So now I have to verify my KVL verification. V in should be equal to V1 plus V2. Is it there? It is 17.176 plus 82.82. If I add those two, if I add 17.176 plus 82.82, can you see now it is 99.996 volts, which we are supposed to get it as 100 volts. Can you see this is almost very close to 100 volts. So your KVL is verified. KVL is verified. So coming to KCL, so what does your KCL says? Your KCL says current I1 is equal to I2 plus I3 plus I4. So it is 171 is equal to this plus this plus this. So it is 82.82 plus 88.1 plus 0.828. Because all of them are in milli, let me note. Can you see it is 171.48 milliamperes. This is your I2 plus I3 plus I4, which is equal to almost very close to it. So there is a small variation because of the truncating the values. Okay, and of course you can also verify this I3 dash is equal to I3 plus I4. So where is that? I3 dash is equal to I3 plus I4. How much is I3 plus I4? I3 plus I4 is, I can just delete this first two values. Okay, this is actually 88.92 milliamperes. So how much was our I3 dash? I3 dash we found somewhere here, no? So this was our I3 dash. What is that? This is I3 dash, you can see here. This is I3 dash. So this is I3 dash using I3 plus I4, which is equal to 88. This is 88.93 milliamperes. So this is I3 dash directly from this one. This is I3 plus I4. So we could able to verify this. So let us do the simulation and try to uh, try to verify the values. Okay, let me do that. Let me rig up the circuit. So I need to have a battery. Battery is there in this miscellaneous. Uh, just click on this battery. Let me place it here, and I want to have a resistor. Okay, resistor is of 100 ohm. I need to have R2. This is R3. Another. Okay, another resistor R4, and then I need another resistor R5. That's fine. Okay, let me now connect. So let me press this W. The wire will come. Now I will do the connection. I'll stop it here. Maybe I will make this so that it fits in. This comes down. Okay. Maybe you can just run through this. Even when you're running through this, it will not be get connected. You can see you can straight away go like this. You can stop here wherever you want, and you can start from here, go all the way down here. Wherever resistor is there, that wire will just eliminate it by itself, and then you need to have a ground. Maybe we can just pause this video, do once or twice. You have to feel that connections. So then again use wire to connect it. I'm using the wire. Okay. Now I will make this voltage as 100. That is 100 volt. Let me do dot op, that is because I want to find voltages and currents. Okay, before that let me change these values. So this happens to be 1000. Sorry, that is 100. It's actually 100. This is 1000. No, we have actually taken the standard values that are there in the lab so that you can verify these values. Don't think, okay, why I have taken 470, because 470 is a standard value available in the labs. You don't have a 500 ohm resistor. This is 100k. Suppose if I do dot op, this is DC operating conditions. Suppose if I do this, I place it here, I will run it. The moment I run, I'll get, okay, I got all the nodal voltage and currents. This is what you have. See, now this is 171. So let me note those values. I just write it in a different color. So I of R1 is 171.76. IR2 is 82.82 milliamperes, and R3 is 88.11 milliampere, and of course these two are same. I3 current through R3 and R4 are same because they are in series. You can these two resistors. So these two resistors are same, and we name this current as I4, which is IR5, which is nothing but 828 milliamperes. Let me show you this, the values that what I got. I have listed them. So where I have listed here. See now, these are our calculated values. These are simulated values. Can you see they are almost matching, almost 100% matching. You can find the corresponding voltages. How do you find voltages? So voltages can be found. Of course, you can see these are the currents. What I got here. You can see these are the currents. You can see this is 171 milli. This is that 171 milli. This is 0.828 milliamperes. This is 0.828 milliamperes. Okay. This is given in terms of 0.000 something. So I just convert it to milli. You'll get these currents. Of course, you cannot see the voltage here. Okay. What all voltages you are seeing here is one is this 100 volt. That is 100 volt is a supply voltage, and this voltage 82.88 is actually this voltage, which is exactly this. You can see this. You are getting this. You are getting this. The other voltage what you are having is okay. If you want to know what is this voltage, this 41.44 is actually this voltage. So this is actually 41.4 uh, 1 volt. So this is between, so whatever 82 you have, that is equally divided between these two. So 100 minus 82 is this, what is that, 17.16. 17.16. So this way we can able to easily verify the Kirchhoff voltage law, current law. So let us proceed with the next question. So next question we have, so we are looking at the next question. So next question what we have is, okay, let me just see. I'm just opening that question. So after this we have this question. Okay, let me write this. So question what I have now is, so I have two resistors. This is 25 ohm and this is 25 volt. This is 10 volts, which is this. We are asked, okay, this is R1, R2, this is 1 kilo ohm, this is 10 kilo ohm. We are asked to find the current. Okay, since we have these two resistors in series, let me assume a current of I1 flowing in this direction, that is moving towards up. So I can just, since these two are in series, I can put as an equivalent resistance R equivalent, which is nothing but R1 plus R2, which is equal to 11 kilo ohm. At this point you have 10 volt, and at this point you have, let me name it as some Vx and Vy. So Vx is 25 volt and Vy is so and so. So if you are looking at this as the current, some I1. So what is I1? I1 is the potential difference across the resistor divided by the resistance. You have to consider this, you consider as higher potential and lower potential. So it is Vx minus Vy by R equivalent. So this is actually 25 minus 10 divided by 11k, 11 kilo. So actually this happens to be 15 volt by 11 kilo ohms. So 15 volt by 15 divided by 11, it is 1.36 milliamperes. 1.36 milliamperes. So now this is 1.36 milliamperes. So what is the voltage up across this? So if I say this as some V1 and V2, this is plus minus, if this is plus minus, what is V2? V2 is actually 10k into this will be 13.6 volt. How much is V1? It is actually 1k into so and so, correct? So it is, or this is actually 10k multiplied by current. So now it is 1k multiplied by the current I1. So since it is k, it's actually 1.36 volt. So as per your what KVL, so if you write the KVL for the entire loop here, this is voltage rise. If you consider this as Vx, so it is voltage rise is positive Vx, and this is voltage drop here minus, let me say it as V2, this as V1, minus V2 minus V1, again this is plus minus, minus Vy is equal to 0. So let me write this Vx minus Vy is equal to V1 plus V2. How much is this? This is 25 minus 10 is equal to 13.6 plus 1.36. So this is to 15. How much is this? 13.6 plus 1.36. Can you say it is 14.96, which is fairly okay. Your KVL is very good. Why it's not exactly same is because we have truncated the values. This is the problem. How do we do that? Simulation. You can remove this. So what I'll do is I'll select, let me minimize this, let me select all of them. Okay, let me retain that voltage source. Let me just take out from here to here. Let me delete it. Okay, this is also removed. What you have now is you have a voltage source. Let me do the way how it is there. So what I'll do is let me just delete this also. Let me start afresh. So let me take a component corresponding to battery, which is I need to have two batteries. Oh, what happened? Okay, let me select this place, one here, other here. I need to have two resistors, R1, R2, then close it, wire them, this going there, all the way down here. Okay, this is coming down all the way here. I can connect it to all the way up here. Then I will use ground. This is grounded. This resistance is how much? 10k. This is now 10k. This is okay. 1000 ohm. This is 10 volt. This is 25 volts. Sorry. if I do dot op and get the current flowing through them, let me do it. So current should be 1.36. You can see you have minus 1.36 milliampere. Why it is minus means because the resistors are connected reverse, and other voltage is 11.32 volt, and let me show you this. So let me rotate this resistor twice. I have this move, select it, control R. This is, I will do this. Do the same thing for this also, control R. Now we can see currents will be in positive direction. See, the currents through both the resistors is 1.36 milliampere, and voltage across the two resistors. Okay, I can find the voltage across through two resistors, for which I have to do a transient response. So I will go here, I will make a transient response. When you're making a transient response, you have to make some timing specifications. Let that time be, okay, let the stop time be 1 millisecond, let it be 0, let it be 1 micro. We have done that. Let me run. So I need to know what are the voltage across this. So this is positive, this is negative. You can see the voltage is minus 1.36. Why it is minus 1.36? Because I have taken this as positive, this is negative. Actually, while solving the problem here, we considered this to be at higher potential. So this is actually plus minus. So while holding my probe, I had to keep this red here and black here. So then only the voltage is having, a voltage of 1.36 volts will going to flow through this. Will be developed across this. So what I'll do is I'll go back here. And I'll measure the voltage, keeping this as, okay, before that I can delete this. How do I delete? So there is a delete option. You can delete this. Then you can measure the voltage from this end to this end, from here to here. That's what is 1.363 volts, 1.36 volts. And voltage across this would be, across R2 would be how much? So that is almost, okay, 13 minus of that, which will be not 13, it will be 13.6 volts. Can you see this 13.6? And if you see the current here, of course current is in the expected direction, so this happens to be 1.36 milliampere. Can you see the current through this is actually 1.36 milliamperes. Sorry, 1.36 milliamperes. This is the current. So this is my circuit diagram. Okay, I can slightly minimize this. These are all different voltage and current, voltage across resistors and current through the resistor. I think you can do the last one. So we see in the class the simulation of the last circuit, which happens to be one of the simplest circuit what we had. So we had this circuit, which is a very simple one. The circuit what we are looking at next is actually this. So you have a circuit corresponding to this is your fourth circuit. this is include, this is 100k, this is also 100k, this is coming, so this is 10k. This is R1, R2, R3. Since these two are 100k, their file combination happens to be half of that, okay, 50k. 50k in series with 1k is 51k. So now we can go a bit fast in terms of, because we know most of the things. So this is now 10 volt. The current I1, the current I1 is 10 volt by 51k. That is 10 divided by 51 exponential 3. So it's actually 196.07 microampere. That is I1. This is I1. Similarly, what is I2? So because whatever I2, I3 is there, they have to be same because you have a same resistor. I2 is equal to I3. Therefore, I2 plus I3 is equal to 2 times of I2, which is equal to I1. So what is I2 then? So then I2 is equal to I1 by 2, which is equal to I3 also. How much is this? I1 by 3 is 196.07 exponential minus 6 divided by 2. It is again 98.035 milliamperes. So this is the current. Of course, naturally the voltage is this multiplied by this happens to be the, sorry, this is mechanical. Actually mechanical. Then what is voltage across resistor? If you name it as V1, which is I1 into R1, which is 196.07 microampere multiplied by 1 kilo ohm, it is 196.07 millivolt, whereas V2 is R2 parallel with R3 into the current I1, into the current I1, whatever overall current flows through this, or it's equal to I3 into 100k. It's also equal to I2 into 100k. So now what is this? So this happens to be it is now 100 exponential 3 into I3 is how much? I3 is 98.035 exponential 6. So you see it is 9 point, this is 9.9.80 millivolt. So what is V2 is? How much is V1 plus V2? So V1 plus V2 happens to be, this can be written as 0.196 millivolt. So V1 plus V2 is equal to the applied voltage. Let's say this Vn. So Vn is equal to V1 plus V2. So it is 90. How much is this? What is this? So we have, this is 1k multiplied by I1 is this. Okay. Exponential 3 multiplied by. So now this is V2 is how much? This is not this is actually 50k, because R2 parallel R3 is 50k. So how much is I3? I3 is okay, it's not I3, it is okay, this is fine. Okay, this is fine. This is I3 into 100k. So how much is I3? I3 is actually this, 98.035 into, so it is 100, 50 exponential of 3 into 196.07 exponential of minus 6. Can you see it is 9.803 volt is not. This is actually volt. This is actually volt. This is V. This is what is V2. V2 is this much. V1 is how much? V1 is 0.196 volt. So V1 plus V2 is equal to input. If you add this is approximately equal to 10. Approximately equal to 10. So this is not millivolts. So this is 9.8 volt. Fine. So this way we can able to, of course, you can just go back here and then do the same thing. So what I'll do is let me delete this. I will delete the entire, deleting it here. So I will use a resistor, control R, and two more resistors here. This is 1000, whereas this is 100k. This is also, click on that R, 100k. Do the connections. This is actually 10 volt. Let me do the wiring. To do the wiring, let me start from here. Okay, and this. I can go here. I can start from here, go down all the way. Okay, so there is some extra wire. What I'll do is I can just fit to scale. Let me delete this. So now there is some extra here. I can delete this. Okay, now I will run. So now this voltage is plus minus, which is 196 millivolts, and this is around 9.8. Can you see this is 9.8, 9.80, and this is how much is this? This happens to be 196 millivolts, and current through them is, so what is, okay, actually you can see the current is showing in the opposite direction. To have the direction to go from left to right, so what I can do is I can simply move this resistor and then rotate it and replace it. So okay, now this is done. So how about this? So let me run this. You can see now this is fine. Okay, now this is ulta. So of course let us see the current here. So current here is how much? 196 microampere. That's what was the expected value. You can see this is the current what you're expecting, 196 microampere, and the current flowing through this is actually half of that, which is 98.0352 microampere. So let us see what the current through this. So you can see, if you see the current through this one, it's actually opposite to the direction what we assume. So that's why it comes as minus 98 something. See here, this comes as minus 98 because the arrow of your current is going in the opposite direction as compared to our assumption. So that's why this current is negative. If you want to get positive current, so since we are moving from here to here, so you have to rotate the resistor. I'll do that. So what I'll do, I will move that control R clockwise, and this also I can move it, control RR. This is done. If I run, you can see this current is also positive. Can you see this current is now positive, 98.03. So that's what we are looking for. The current what we are looking for is 98.03 microcurrent. So this way you can comfortably do all the simulations. So that you can verify all those circuits from the what equations to the simulations. Thank you.